Hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. So it says you are given an array ARR where ARR of I denotes a range of working hours of a person at a position I, which it can cover. So ARR can be -1 or any other number. Now, what if -1 means? -1 means the person is unavailable and cannot cover any time. But ARR of I rather than -1 says us that person at index I can work and cover the time interval of I minus ARR of I and I plus ARR of I. So if ARR of I is 2, it can cover 2 distance forward and 2 distance backward. Now let's say how what we asked. So the task is to find minimum number of people required to cover the entire working day from 0 to n minus 1. If it is not possible to fully cover the day, return -1. Nice. So we are provided with an array such like this, and the output is 1 because when you choose 2, which was at index 1, we can cover fully previous to it, and 2 sides beyond this, that means 1 is covered, 0 is covered along with this. So all of this beyond and all of this previous is covered. So entire array is covered by only one worker, which was 2. So that's the reason only 1. Here, no matter how hard you try, it cannot go beyond this point. So it's -1. So ultimately, if you take 4, so you can take 4 jumps over there, 1, 2, 3, 4, and you can reach at most this point. If you can take 2, still you can reach at this point. So beyond this point, there is no way you can do n-1 and n-2 operations. So this last 2, n-1 and n-2. So that's why -1. Similarly, -1 here as well, because you can cover these positions, but you cannot cover the last one. So yeah, we have provided with few constraints, and let's see how we can go ahead with this one. I'll copy a few one example from this, and we can see how we can approach this problem first of all. So we have this array, an input array. One thing which can come into your mind is how I can solve this problem is what if I can take one by one each worker and test it how it can do my problem. So yeah, we can take all those combinations of worker can do a problem, cannot do a problem, and take the minimum out of them. So you have n workers. N workers had 2 choices that can or cannot span, and that would give you a total of 2 to power n. Obviously that's not what you want. Again, one thing you can do is, hey, I'll start with one worker. I'll check whether this worker can do everything. I mean that I'll start with index 0. If one worker can do till this point, that's good. Then I'll check if it is possible, not possible. I'll go with the next worker from that point, and yeah, in that way you go 1, then you go, I'll choose a 0 index, then you go 2, 1 index, then you go 2 index, and all that. But this won't guarantee you that, hey, you're getting the minimum number. Although likewise you can iterate from not 0, but next time you can iterate from 1, checking can one solve this problem or not, and likewise. But still it's not an optimal approach. But how can we do this? How can I solve this one then? The sum, the array where it has 1, 2, 1, 0. So let's think it in a naive way. If I was given a problem in the real world, how would I solve this one? So obviously I would check that, hey, can this guy over here, can this guy solve my problem? And if yes, how much he can solve the problem? Now obviously this is not a -1, so I can go one jump beyond, so it will go till this point. Nice. But if I'm considering the guy over here too, it can go not only till this point but till this point as well. So shall I choose 1 or shall I choose 0? Let's see this question first. Shall I choose 0 or 1? That means index. I'm speaking about index. Okay. So shall I choose this index or shall I choose this index? That's a good question. Once we know that, we can choose that, and once we choose that, we increase the count and we will make minimum choices and we will get the minimum count. That's how I'm planning. How can I get minimum choice, minimum count? Obviously, why I'm having a count and why I'm having a choice is because I can get this task done either by both. What task? The completion of operation at 0 index. I can either take 1 or either I can take 2. So 2 people are doing this. Do I want 2 people? Maybe, may not be, but obviously, sorry, I don't want 2 people. Obviously 2 people can do this. Why I don't want 2 people? Because I want minimum. What can I do here? What can I do here is I can separate them into intervals. What this means? I can have an interval within which I know that, hey, this is an interval, and within this interval there are multiple people who are eager to solve. So within the interval, multiple people to solve the problem, and within that people I'll make a choice. Yeah, that makes sense. So if I'm having an array as like this, in this case the range would be from this 0 to like 1, let's say 2, this is 3, 4, 5, it is 5, right? So I'll quickly write it down. 5, this is 6, 7. Yeah, so the first range would be 0 to 6. Yeah. Why? Because 6 is the position where we can go farthest, and within 6 there are multiple candidates. There are 4, which is the best candidate so far. There is 3, there is 2. I'm taking numbers right now. So yeah, so there are multiple candidates and we have to choose over them, and there's the rest of the interval, which is 7 and 8, 7 to 8. These are indices again, and I can go ahead and choose someone from this one. Obviously the answer would be in 0 because you cannot choose from this array. No one can span anything here. But the gist of this idea is we are solving this in a targeted fashion. We target this one and we'll solve that one. Cool. Let's go ahead first of all with having an interval, and then we can go ahead and start with how this interval will play and how this interval will help us in solving the problem. So first of all, we wanted an interval. I'll take an integer array. We'll call it as interval, or equal to new list of array list of. Yeah, this is how my interval would look like. Next, what I wanted to do here is I wanted to iterate each and everything and fill the interval. So for int I is equal to 0, I is less than a dot length I plus plus, and I'll say that, hey, if a of I is equal to -1, I don't want this within an interval because this won't contribute anything. So continue to the next while, and interval dot add, I'll add new int, and this would be from I plus, or I'll take first I minus a of I and I plus a of I. Again, there can be situations that we are exceeding the boundaries, so let's adjust the boundaries. Mat.min or mat.max 0 comma this and within here mat dot min with a dot length -1 comma this. So we have adjusted the boundaries right now, and what we'll do is we'll sort this one. Why we will sort this one is we wanted to sort bit by starting point. So interval dot sort with sorting point, that means starting point, that means I wanted underscore I underscore j, so that is underscore I of 0 minus underscore j of 0. We wanted this because I want every start as like every interval to begin within the fashion that hey, I'm iterating from 0 to n, I'm iterating from 0 to n, so I want everyone to start early, because I will consider those early points first and then I'll check the later part. I will consider early points first and then I'll check upon the later parts. That's what I'm doing. Cool. Now there is a point how we are going to utilize this interval. You see, what do you want here? We want a count, and that's the thing which we are returning ultimately, right? Nice. We also wanted to understand that how farthest my approach goes. So farthest, which initially is -1 obviously, because I don't even know whether I can even consider this 0 index or not. So how farthest I can go is denoted by this, and my target would be that I should achieve this farthest if equals to a dot length -1, then it means I have achieved the goal. And yeah, while doing this, what I'll want is an iterator as well. I'll iterate one by one from the start itself. So why not I'll have a while loop which would say hey, farthest until and unless I'm lesser than this guy over here, a dot length -1, I'm lesser than that guy. So do one thing, try making me farthest again. Okay, I'll try making it farthest. He'll says, and how far you can go right now? So I can go right now farthest this point, correct? So what I'll do is I'll have an interval. Interval would be given by this intervals. I'll write down here intervals for better naming. Okay, from this intervals I'll get I, okay, or if I can have a size, get I, and what I want from this I is hey, whether I can reach this point or not. And if I'm reaching this point, how can I know that if my reaching point, that is my starting point, is less than or equal to farthest +1. Okay, digest this for a minute, that hey, I only wanted to, now here my logic of extending would go, extending the span. Now here my logic of extending would go when I am reaching at the interval start. The prerequisite or the criteria here is I should at least be in the beginning of the interval. So I have this interval, this one. So if I can reach at most till this interval, then I can go think about extending. If at all, think it like this: if at all I cannot reach this point, forget about extending till 6, forget about extending till 7, because I cannot reach even till 4th location. That is what it denotes. Again, few syntax and corner cases. If I'm getting it directly I, so I should make sure that hey, I is less than interval dot size, else it would give me index out of bound exception. Now cool, I'm planning to extend, that's a good one. and that's what we are looking for. So that means farther I can go should extend. It would be maximum of currently how far I can go and how far this interval can get me. So if this interval can get me to, I don't know, intervals dot get of I of 1. So this is the ending point, 1 is the ending point. So interval can get me to this ending point. I'm happy. My far is again way beyond. Far is extended, and my far is extended. I have covered this interval. Let me go to the next interval, I plus plus. Ultimately, the moment my farthest cannot reach any far, I have to check. I have to check my farthest and update it. So I wanted to update my farthest is equal to far. So I'm updating it over here. But there can be a case where far is lesser than or equal to farthest. What does it mean? It means that your far element which you tried to extend, it didn't even extend it. It didn't even extend it, and it stayed till this point, or till this point in our example, it stayed till 6 itself. Thanks to 4, it went till 6. Thanks to 2, it went to 6 again, but it never went beyond 6. So in this case, we wanted to return -1. Okay, good. So far so good. Now we are returning -1. I have updated my far. That means I have took a step. Means I have wanted to increase the count. So took step, increase the count, extended my farthestness, and that's how I'll proceed now. Let's compile this code for any compiler errors. None seen so far. Let's submit it for rest of the test cases as well. Yeah, it got accepted. So the approach we have tried over here is much more like a greedy approach. We have not chose the entire combinations, like hey, can we do this, can we do that, but we have chose that hey, 4 can give me till 6. Can I go beyond 6 or not? Forget about the rest of the elements. Tell me beyond 6 just. So much like a greedy solution, not waiting for or not computing all the possibilities. So yeah, the expected time complexities were this, and we pretty much respected that. Topic tags were obviously greedy and sorting. So this was one of the problems from Geeks for Geeks, and with a greedy and sorting logic. For more such problem, click the video on your right, and I'll see you in the next one.